Hi everyone, welcome for today's tutorial. In this video, we'll learn how to determine the radius, center, and interval of convergence of a power using the ratio test. Understanding power series is super important for analyzing function and solving differential equations. So, let's get started. Let us first define what is a power series. A power series is an infinite sum of terms in the form f of x is equal to the summation of a sub n times the quantity of x minus c raised to n from 0 to infinity, where a sub n are the coefficient which could be constant, x is the variable, c is a constant called the center of the series, n is the index of summation which typically starts 0 and goes to infinity. A power series represents a function as an infinite sum of terms where each term involves a power of x minus c. The function fx is defined as the sum of terms in the series for certain values of x. Center of convergence. The center of a power series is the point C around which the series is expanded. This is the value of x at which the series is centered, and it determines how the terms are written in the terms of x minus c. The power series is usually written as a series of terms involving x minus c raised to n, because the series is expanded around this center. Radius of convergence. The radius of convergence of a power series is a number that describes the range of values of x for which the series converges. In other words, the series will give a valid result only for values of x such that the distance between x and the center C is less than r. Mathematically, the series will converge when x minus c is less than r. If x minus c is greater than or equal to r, the series will diverge, meaning it does not give a valid result. We can determine the radius of a convergence using methods such as the ratio test or the root test. Interval of convergence. The interval of convergence is the actual range of x values for which the power series converges. It is typically represented as an interval around the center C, such as C minus R and C plus R, where the radius of convergence is R. However, we need to check the endpoints of this interval. X is equal to C minus R and x is equal to C plus R separately. At these endpoints, the series may either converge or diverge, and this requires additional testing. So, the interval of convergence is the set of all x values where the series converges, which could be an open interval, a closed interval, and a half-open interval. Let us take note to this table. We have the possible ratio test result is equal to 0, and when the x values for all x, our radius is infinity and our interval is negative infinity to infinity. And when our possible ratio test result is infinity and our x values is equal to c, then our radius is 0 and our interval is c or the center. Then if our possible ratio test result is equal to u times r, our x values is interval of x may or may not include endpoints. And our interval is times the quantity of negative r plus c and r plus c. And now, let us proceed to the examples. Example number 1. In our example number 1, we have the summation of x raised to n over the n factorial from 0 to infinity. After that, we need to apply the ratio test. And the formula to find the ratio test, we have an plus 1 over an. And after that, we need to substitute to the original given. We will have an x raised to n plus 1 over n plus 1 factorial. And after that, we need to find the reciprocal of our original given. We have the n factorial over x raised to n. And after that, expand natin yung ating given para magkaroon tayo ng cancellation. And x raised to n plus 1, pwede natin siyang i-expand into xn times x. Iisa lang din naman ang meaning niya. Then yung n plus 1 factorial, pwede natin siyang ang maging n plus 1 times the quantity of n factorial. Then times the n factorial over x raised to n. Then after that, cancel this like terms. We have yung x raised to n at n factorial. And after that, copy lang natin yung natira. Magkakaroon tayo ng x over n plus 1 dahil yun na lang yung natira sa ating cancellation. And now, magkakaroon tayo ng sagot na 0 dahil alam naman natin na kapag sinubstitute yung infinity and dot, it is equal to 0. And 0 is a converging. Then, kanina na-discuss natin about the table na kapag ang nakuha nating value ay 0, our radius is infinity and our interval is equal to negative infinity to infinity. And our center is equal to 0. Example number 2. And for our number 2, we have the summation of n factorial times x raised to n from 0 to infinity. Then we need to apply the ratio test. We have the an plus 1 over an. Then substitute to the given or the original given. We will come up to the answer of times the quantity of n plus 1 factorial times x raised to n plus 1 over n factorial times x raised to n. Then we need to expand the given, the n plus 1 factorial magiging times the quantity of n plus 1 times n factorial at yung ating x raised to n plus 1 is equal to x raised to n times x over n factorial times x raised to n. Then we need to cancel like terms, so we will have the answer of n plus 1 times x dahil yun na lamang ang natira si ating cancellation. Then after that, substitute the infinity to n plus 1 times x. Magkakaroon tayo ng infinity plus 1 times x. And infinity times x is equal to infinity. So, based on our table, kapag ang ating nakuhang sagot ay infinity, magkakaroon tayo ng radius which is equal to 0 and our interval is same as our center which is 0. Okay, that's it for our examples. To summarize, we've learned how to use the ratio test to determine the radius of convergence, which tells us how far from the center of the power series the series will converge. We also discuss how to find the interval of convergence by checking the endpoints. I encourage you to try out some practice problems to get comfortable with the process. The more you practice, the more confident you'll be with the Power series. If you found this video helpful, don't forget to like and subscribe for more tutorials. Thanks for watching and happy studying!